Okay, so let's do another example that involves space theorem. And that is a little bit more complex, so that will take a little bit longer, but it's very important to understand it. And there's a little bit more to it, which is important for a field which we call decision analysis. So let's go over everything step by step. So assume that there is a firm that needs to decide to develop a new product or stay with the current. If the firm stays with the current product, it makes a profit of 10, and it knows that for sure. But if the firm introduces the new product, there is a 50-50% chance that the new product becomes a hit or a flop. And if the new product is a hit, the firm will make a profit of 20, but if it's a flop, it will make a loss of 10. So now we can convert that information into a decision tree. Forget about everything else that you see so far here. So there's a decision tree. So a firm needs to decide, shall we introduce the new product or go with the current? So a decision node is captured by a solid dot. So now the first decision is, shall we go with the new or shall we go with the current? So we can either go with the new or the current. So when you go with the new, you think, and that is your personal assessment, so that's a given, that there is a chance, and in the decision tree, whenever Mother Nature kicks in, that's a hollow dot. Whenever you need to make the decision, that's a solid dot. So now Mother Nature kicks in, and Mother Nature can reveal that your new product will either be a hit or it will be a flop. And you think, you believe, that's a given, that the probability of this being a hit is 0.5 and it being a flop is also 0.5. So the probabilities after a chance node, they always need to sum up to 1. Okay, so now we still can add the payoffs. We know if it's a hit, you make a profit of 20. If it's a flop, you lose 10. If you go with the current, you get 10 for sure. So now we have translated the problem into a simple decision tree. Let's just stop here and assume you don't have any additional information. Would you introduce the new product, yes or no? So in order to answer the question, you would calculate the expected value from introducing the new product and compare it with what you have for certain, which is going with the current. So the expected value of introducing the new product, I'll write that here, expected value of introducing the new product would be, you can expect with a probability of 0.5, a profit of 20, and with a probability of also 0.5, you can expect a loss of 10. So you can expect 0.5 times 20, 10 plus 0.5 times negative 10, 10 minus 5, you can expect to make only a profit of 5. That's the expected value. Well, since this is obviously less than the expected value of the current, that is less than the expected value of the current, and the expected value of the current is essentially a certainty. The decision is you will not introduce the new car, you will go with the current. Okay, so without additional information, you would go with the current. But now let's assume that you could have access to additional information. And there is a concept which is called the expected value of perfect information. The expected value of perfect information. Expected value of perfect information. So let's assume that God knows whether your product will be a hit or a flop, and you could ask God. So then you would approach God with an initial probability of 0.5 that it's a hit. But now God tells you, yeah, it will become a hit. So what do? Do you introduce the new or the current? Well, you obviously introduce the new because you know it will be a hit and you will make 20. But you also initially approach God with a probability of 0.5. And let's say God tells you now that it will be a flop. Well, then what do? You obviously will not introduce the new car and make a loss of 10, but go with the current. So by consulting God, you could expect now an expected value of perfect information, which is 15. 0.5 times 20 is 10, plus 0.5 times 10 is 5, so 15. So that means you would pay up to 5 units to consult God in order to get perfect information, because that's the value. So if you could talk to God for a value of 4, yeah, then you would pay that because you could expect a value of 15 which exceeds the current payoff of 10, which you have for sure. So consulting God would increase your payoff to the expected payoff to 15, so you would pay up to 4. So the willingness to pay for perfect information is the expected value of perfect information minus what you have for sure, which is the 10 associated with going with the current. So that is the expected value of perfect information. It's an important concept. But of course, we don't have perfect information. But let's just keep that here for later. We calculated the expected value of perfect information as 15, because we have to come back to that later. Okay. So, but next, let's assume you have imperfect information. And the industry that's responsible for imperfect information is the consulting companies or marketing companies. And let's assume that you could consult a marketing company. The market company will look at your new product and will evaluate it and will come back with a verdict that says, we think it will be either a success or a failure. So the marketing company will not tell you it will be a hit or a flop, but with something similar. So now you can think of expanding your decision tree by handing over your personal assessment to a marketing company. And now they can come back with either a verdict that says, we think that your new product will be a success, or it will be a failure. Okay, and that can of course happen for either branch of your personal assessment of your new product. So in other words, the consulting company, they look at your product and they somehow think, it will be a hit, and then they come up with either a verdict of success or failure. So Okay, so this decision tree is now simply expanded, and the way you can think of it, initially you thought, okay, shall I introduce the new product, yes or no? If I don't have additional information, I go with the current, but now I consult the advice of a marketing company or consulting company, and they can either come back with a verdict of success or failure. But that consulting company, they look at my product, and somehow in the back of their mind, they think, that looks like a hit. And then you have now to make the subjective probability. What's the probability if they look at my product? What's the probability that when they look at my product and somehow actually think it is a hit, that they will report, we think it will be successful. So that is a conditional probability success. They look at the product, somehow you think, they look at it and somehow think it is a hit. But this is a subjective probability hit. So given hit. Or they can look at it, of course, and then you also have to think, what's the probability if they look at it that they will conclude it is a failure when they actually like the product and think it is a hit. Okay, the same. What do you think they will come back and say this is a success? If they look at the product and actually think it's actually a flop. Okay. Or you have to ask yourself, what's the probability when they look at my product and they think, that looks like a flop, that they will conclude it is a failure? It's probably very high. But those are now subjective probabilities. That's why I made them in green, and they are given to you. I have it here. What's the probability of a success given hit? This is what you think. So you think they look at my product, they somehow think, it's a hit, then what's the probability that they will conclude it's a success? It's probably pretty high. Let's assume you think this is 0.8. And again, those are given to you, so you don't have to worry about it. But of course, after each chance, though, the probabilities need to sum up to 1. So the probability that they look at your product, think it is a hit, and then conclude with a failure is only 0.2. But if they look at your product and they think, it looks like a flop, what's the probability they come up with a verdict of success? It's only 0.1. And again, it's given. You don't have to worry where that comes from. That is a given. So this information here in the slides, that is given to you. So those are subjective probabilities which are given to you. Okay, so this is then here 0.9. So what you do now is you await from that consulting company a verdict. And if they come back and they say, what, we think it will be a success, that's good news. And what this will do is your initial probability when you thought it will be a hit was 0.5. But now that marketing company comes back and tells you we think it is a success. So what now happens is that your probability that initially was 0.5 for a hit, given that the marketing company thinks it will be a success, it's probably going up. And likewise, so what you want to know is what's the probability that it's a hit when the marketing company tells me this is a success, or you want to know what's the probability now if it's a flop when the marketing company tells me it's a success. So your initial assessment that it will be a flop of 0.5 will probably go down. But of course, it could also be that the marketing company comes back and tells you it will be a failure. So now you want to know what's the probability still that it can be a hit when they tell me it's actually a failure. So that probably reduces your initial probability of 0.5. And likewise, what's the new probability of a failure given that the marketing company actually flop? That should be flop. So you think your initial probability that a flop was 0.5, but now the marketing company tells you anything it will be a failure. That probably increases the probability of a flop. Okay, so now let's take a look at this decision tree here again. So you passed on the information about your car, and now you await a verdict of success or failure. So initially you thought, and you approached the marketing company with an initial probability of 0.5, and they don't give you perfect information like God, but imperfect information. So the probability associated with each branch of the decision tree is here. So here there's a probability of success that it ends up, which is your initial probability that you thought it is a hit, times, let's make that in green to be consistent, probability of success given hit. Then here you approach the marketing company with an initial probability of hit times the probability now that they come back with a failure given hit, and you see the difference to perfect information. And so we multiply now this through, so you approach a marketing company with a 50% probability, and then you think there's a 10% probability they come back with a success verdict. So that is probability flop. Times the probability of success given flop. And lastly, you approached with the probability of 0.5 flop. Okay, so this is where we stand so far. So we can actually multiply here through what are those probabilities. So that basically tells you, if we multiply through, what's the probability that you can expect a success if they come back with hit. If the marketing company, well, what's the probability, that you approach a marketing company with a hit, and then times your subjective probability that they come back with, a success. So that is multiplied through 0.5 times 0.8, which is 0.4. The second branch is 0.5 times 0.2, which is 0.1. So, and here we have 0.5 times 0.1, that's 0.05. And here we have 0.5 times 0.9, which is 0.45. Okay, so what that tells you now is, okay, so there is a 40% chance, that when the marketing company looks at your car and thinks it's a hit, that they come up with success. But there is another 5% chance coming from looking at it after it is a flop. So in other words, there is a 40% chance that your decision tree ends up with a success here, and another 5% that it ends up with a success coming from that branch. So in other words, the probability that you get a success verdict is 0.4 plus 0.5 or 0.45. The probability that you will receive a failure verdict is now 55. And again, this is all driven by your subjective probability. Just like you approach that marketing consulting company with an initial probability, but then you can get either success or failure in return. And the same happens with flop. So in total, the probability that something comes out as a success is now 45%. And the probability that you will receive a failure is now 55%. Okay, so now let's take a look at this one. Ultimately, you know they can come back to me and they either report they think it will be successful or it will be a failure. But what you want to know is what's the probability that it will be a hit or a flop, which is of course closely related to the verdict of success or failure. But if they come back and the marketing company tells you it will be a success with a certain probability, well, that's good news. So how does that affect the probability of hit? Initially you thought it is 0.5. The point here is if they come back to you and tell you it's a success, the probability of hit should go up. But what is that probability? Well, now we can use Bayes' theorem. This is the probability of hit times the probability of success given hit over the probability of success. Here, same thing, it's a similar thing, probability of flop times probability of success given flop over probability of success. And here probability of hit times probability of failure given hit over the probability of failure and the last one is the probability of flop times the probability of failure given flop over the probability of failure. This is what you ultimately want to know. So now look at what you want to know. You want to know what's the probability of hit. You approach, so the way to think about it is you approach the marketing company with an initial probability that it is a hit, and then you thought, okay, what's the probability if they look at it and they think it is a hit that they come back with success over the overall probability that they come back with a success probability. So we already know the overall probability of success is 0.45. So here in the denominator we have 0.45. Here in the denominator we have 0.45. Here the probability of failure we have 0.55. But what about the denominator? Well, the probability of hit times the probability of success given hit. We can already see that here, because if we draw out the decision tree and we basically think of it this way, that our initial assessment of the new product with the probability that it will be hit of 0.5 and then a flop of 0.5, we passed on that information to that marketing company. They look at it, and based on what they think might be a hit, they come up with a success probability of 0.8, or they come up with a success verdict. The probability you think is 80%. So if you multiply that through, you get a 0.4. Here, probability of flop given success, that is 0.05. Here, flop given success, so probability of flop times the probability of success given flop, that's only 5%, which makes perfect sense, right? I mean, if, let's say, that marketing company comes back and tells you it will be a success, the initial probability that this will be a flop will go down. And last one, probability of flop given failure. Probability of flop, okay, that's the 0.45. Okay, so now if we calculate those probabilities, I have it here. Probability of hit given success, that increases now your probability to roughly 89%. But when they come back and they tell you, we think it will be a success, now you think that the probability that your car will be a flop, or if it's a car, your new product will be a flop, it's now only 11. And you think, if they tell me that it's a failure, you think it's a hit, it's now only 18%. And likewise, you think it's a flop, and there's now a higher chance of 82. Okay, so those are now the updated probabilities for hit and success, given additional information, which however is imperfect. Okay, so now we can take this information and use it in order to analyze how much are we actually willing to pay for that marketing company. So we can think of a decision tree. So we have to decide, shall we consult, yes or no? So we can consult. So it is similar to what we did now with the expected value of perfect information, or we cannot consult. Okay, so when we not consult, we already know, and we just decided earlier, because the expected value from the new car is less than the current, we go with the current and we get 10. Okay, when we consult, two things can happen. So now this is a chance node. The first thing that can happen is that they tell us it will be a success. Or it will be a failure. When they tell us it is a success, I have to decide, shall I introduce the new or the old? So I need to, maybe that's a little bit too long here. Maybe I can. Okay, so now next I need to decide. So the consulting, they come back and tell me it's a success. So now I need to decide. So that's a decision tree. Shall I go with the new? Or shall I go with the current? Okay. Well, if I go with the new, there is a chance that it becomes a hit or a flop. So that's a chance node. Okay, and I have to do the same if it's a failure. So when they come back to me and tell me it's a failure, I have to decide, shall I go with the new or with the current? And if I go with the new, there is a chance that it will be a hit or a flop, or I go with the current. Okay, so now let's pay off the payoffs. Whenever it's a hit, we know we get 20. Whenever it's a flop, negative 10. Whenever we go with the current, it's 10, 20, negative 10, 10. So now what we need to do is we need to enter the probabilities, and then we can go through the decision tree. Okay, so the probability of success we already calculated as 0.45. .45, the probability of failure, .55. Okay. So, but now what did we say? So then we have to decide if it's a new. So the probability that it's a hit, given that it's new, I mean, if it's a success, so the probability of hit given success we calculated as hit success 0.89. And the probability of flop given that they tell us it will be a success was 0.11. Again, after each chance node, the probabilities need to be equal to 1. Okay, so now here, what's the probability that it will be a hit, given that it's a failure? So that was 0.18. And the probability that it's a flop, given that the marketing company thinks it's a failure, that was 0.82. Okay, so we have now converted this information here. Maybe I can now erase that information. We also have it here again in small, so we can calculate now the expected value of imperfect information. So okay. Okay, so what's the expected value of imperfect information? So okay, expected value, I call it imperfect information. Okay, so now we know there is a 45% probability that when we consult, that they come back with success. And if they come back and tell us it is a success, we expect with 89% probability, 89%, 0.89, we expect a gain or profit of 20, 0.9 times 20. But also with an 11% probability, a loss of 10. Okay. So how big is this? So the expected value here is so the expected value of consult and success is here. So they tell us it is a success. So it's 0.89 times 20. Actually, let's quickly calculate it here. So let's just consult here quickly Excel. So we would say equals 0.89 times 20 plus 0.11 times negative 10. So in other words, when we introduce, so if the consulting company tells us there will be a success, they think it will be success, and we introduce the new one, then we can expect an expected value of 16.7, which is greater than the current, which means we will go with the new one, and we eliminate this one. Okay, but there is also a 0.55 probability that they come back and tell us it will be a failure. Then if we introduced the new one, the expected value of the new one would be, so now we would have to say the expected value of introducing the new one is making a profit with probability of 18. We make a profit of 20. But with a probability of 82%, we make now a loss of negative 10. So that will give us a loss of 4.6. Well, in this case, if the consulting company comes back and tells us, we think it will be a failure, you will not introduce the new car, but you will go with the current, and you can expect a profit of 10. Okay, so in other words, when they come back With a failure, you expect an expected value of 10. If they come back and tell you they think it will be a success, you get 16.7. So the overall expected value of this imperfect information is equals to 0.45 times, let's do it complete again. Okay, it's a 16.7, we already calculated that. 16.7, or we can, the 16.7 was obtained by 0.89 times 20 plus 0.11 times negative 10, and it's at 0.15 but 0.45 plus there's a 0.55 chance that you get to 10 times 10. So that's 13.015. So that expected value is only 13.015. Okay, so what is important, is to eliminate the things if you get a failure, that you don't go with the new product but with the current. So now we have imperfect information. When we had perfect information, the expected value of perfect information was 15, now it is only 13.015, which is much less. So it's lower quality information, our willingness to pay is less. So our willingness to pay is always the expected value of the information minus what we have for sure. And what we have for sure is always the 10 if you go for the current. Anyhow, so that was a long problem set, but it's an important one because Bayes' theorem is really important in decision analysis. And I didn't know how to break it up a little bit in shorter sections, but I hope that is clear and you can see, how subjective probabilities can enter a decision tree. Okay, let's stop here, and I hope that was useful.